to this beautiful and wonderful morning. This is your host, Miss Shatakshi Mondal from CSI Student Chapter of SJCEM. I welcome to all our participants for the third day of hands-on session on data mining for beginners by Dr. Kranti Ghag ma'am. Once again, we welcome you dear ma'am. On this fresh morning, we request all our participants to turn on their camera to have a group photo at the start of the session. I once again request to all our participants to turn on their camera to have a group photo.
Done, Satakshi.
Okay, thank you. And now I would request you, ma'am, to start today's hands on session on data mining for beginners. Over to you, ma'am.
Yeah, thank you, Shataksh, for a very nice beginning. I mean, this is a Sunday morning where people are resting, have a cozy, comfortable Sunday. But in spite of Sunday, I have a crowd. Let it be a few ones, but these are the ones who will be, the excellent data scientists of the world ahead, I'm sure. Because you've kept your comfort aside, and keeping it aside, you're trying to do something very nice will be surely helpful to you. Firstly, I congratulate you all for that. And now let's begin. I'll share my screen. I'll also share, I hope you all have downloaded the dataset which was shared yesterday. If not, you can just quickly download it now. I'm sharing the link of the dataset in the chat. I'll share the notebook link after some time. We'll go with some initial discussion and then I'll share the notebook link. Before we go ahead, do you face any difficulty somewhere in what we learned till yesterday, or was it fine? So should we go ahead with current session, or do you have any doubt? So if we go ahead with current session, say yes. If you have a doubt, say doubt. Ajay, you've typed yes D. Does that mean yes with a small doubt, or was it a typo? I think it should be a typo because yes, you were quite interactive. Yes, yes, it's a typo. Okay. So coming to our presentation, I'll share the screen. Give me a moment. Is the screen visible? Yes, fair enough. Yeah. So what we discussed up till yesterday was a tabular kind of data, your machine learning algorithms, as we have seen the calculations that we did in decision tree yesterday, that entropy minus pi log pi on every column, and then you get the final classification being done as fraud or no fraud. Okay. So this kind of data is called as a structured data. It is clearly in a tabular format. It has a definition. So trust level means having a value between 0, 1, 1 to 6, or quantities will be some integer value, grand total will be some float values. This is a structured data. But another domain of the data which is available to us is a unstructured data. Now, what is this unstructured data? So I'll come to it. Let us first begin with this presentation, a short presentation, so that we can come to the notebook very easily. By the time, if you have not like downloaded the data set, I have shared the link over here in the chat. This is the data set which we'll be using for today's sentiment analysis. Okay. Yeah. So to begin with sentiment analysis, see data mining, there are many sub areas out of which one is NLP, that is natural language processing. Natural language is what we talk. Like we say, we talk in English, we talk in Marathi, we talk in Tamil. So these are natural languages. What is computer's language? Computer's language is language like C, Java, Python, and all those things. Okay. So what we are attempting to do is, in this case, is make the computer understand the natural language. Up till now, the systems were such that you actually write the queries or you actually write the code where the system understands what is to be done. Okay, you tell system do this job, it automate the job. Now also you want to automate the job, but you want to make it to a larger reach. Take the examples of all these devices, Alexa, Google Nest, and all. You are talking in natural language, and the device is doing the job for you. Now, when this is to be done, there is a lot of responsibility which comes on this data scientists or the engineers who are converting your natural language into the understandable format for these machines. Okay, so that is one thing. Like there are many things that come under data mining. One of the thing is natural language processing. Okay, and under natural language processing, there are a lot of things that come. One of the thing is text classification. So you classify text on certain criterias, like you classify the text as spam or not a spam. So if you get a message or a mail, you try to get, or nowadays you get the different tabs in your Gmails, that is updates, promotions, and all those. So that's happening based on the subject or based on what you have viewed earlier. The tabs, the mails are automatically diverted to one of these boxes as inbox or updates or promotions. Then there you can make more also. Yeah. And this text classification has again one specific application, just like I gave you an example of spam classification. There could be some other like document clustering. So you want all the similar documents to be together. So when you do a actual typical query search, document clustering happens. So you type by a keyword, and whatever are the documents related to that keyword are displayed to you. Okay. One of the popular applications is sentiment analysis, and this as a huge market. Right now, a lot of things happening in sentiment analysis, and everyone wants to know what their customers feel about them. Like we're going to go into details of this, and these are typical things what you do in sentiment analysis. Okay, so I've just given you an idea. News article classification could be as food, sports, or politics, and these are the other applications of text classification. I've already told you this. Yeah, sentiment analysis just have if someone wants to watch a movie right now, not possible for of course we do on watch on Amazon Prime and all over online, even on TV. But if someone has to go to, or even let us say you're watching on Netflix, Amazon Prime, and all these mediums, so online media, okay, and you want to decide which movie do you want to watch, and if you were there, say, of course, to some 20, 30 years earlier, these mediums were not there. But if you want to go to theater and watch a movie, you would ask either your colleagues, critics, relatives, or friends. See their opinion, and on that basis, decide whether you should go for a movie or not. Okay. The current scenario is slightly different. You just go, you see the review comments, you see thumbs up, thumbs down. maybe on your mobile, on your tab, on your laptop, computer, and you get the comments which the people around the world from different genres, from different age groups, from different locations, with different, they have whether what do they like or don't like, whatever is their opinion, they have given it all about that movie, and you attempt to process this like the data scientists who are doing sentiment analysis attempt to process this and present to you as whether this movie is liked or not liked, and that is what is sentiment analysis. So they collect all the things written by these people around the world, do a little bit of pre-processing, do computation, that this is our actual classification thing, where you do classification and then present into forms of visualizations or the actual outputs, whether it is liked or not liked. Okay. In simple terms, this is sentiment analysis. Typically, you will find the words like sentiment analysis, opinion mining, opinion classification, sentiment classification used interchangeably. But see, when you do this part, when you do actual classification, computations of sentiment analysis, this is sentiment classification. Opinion blows at a slightly outer level. It is, more, it involves sentiment analysis for a amount of time and for a huge mass. Okay. Now, before going ahead, is there any doubt till now? If no doubt, just say clear, or if there is any doubt, please ask here. Okay, I mean Krishnan, Aditya, Ajay, Sohan Lal, Divya, Shubham, Priyanka are saying clear. Okay, Saloni is also saying clear. Let's okay. Quite a few of you have said clear, so let's go ahead. If any doubt, ask at any point of time because let me tell you, very this is a very good medium to learn in these online classes, or rather trainings like this, where maybe it online or maybe it offline. But a lot of things can be you can ask anything. When you read, you cannot ask that person, "Oh, what is this?" Okay. So these are typically the things that you do in sentiment analysis or can be done in sentiment analysis. That is, polarity can be classified whether the review is positive or negative. So someone has written a review about movie on, let us say, bookmyshow.com, and then it could be classified as whether the review was positive, negative, or it was someone just told the story or gave some general details and it was a neutral review. You can find out whether there was any sentiment into it or whether there was no sentiment. So subjectivity is about whether there was. So I say that the mobile is nice. I say mobile has 4 GB RAM. So 4 GB RAM is an objective type of sentence. It has information about it. But I say mobile is nice, has a sentiment into it. Okay. Intensity. The movie was boring. Oh, the movie was so boring. I could not bear it at all. That is, strongly negative. Or boring is just like moderately negative, okay, acceptable negative. Movie was good. It was too good movie. So there's an intensity into it. So identifying the intensity is also one of the aspects where people do research on. Identifying the emotion, whether there's a joy, whether there's a surprise, whether there is anger. I was working on a project along with my students where they were trying to recommend the music, and they're typically trying to recommend on the basis of what the person has listened earlier. Okay, so I was trying to tell them it's not like if I want to listen to a song, maybe I listen to a different song early morning, maybe I listen a different song somewhere in the evening, and I listen a different song late night. So based on what I have listened up till now, it is really difficult to do, or it is not a complete thing where you can do a emotion, you do a recommendation. So I suggested you try to identify the mood of that person at that time, and based on that, so your app should request the permissions for either for some of the social media where the person types, or any of the communication media like messages or chats, and on that basis try to identify the emotion of that person and then recommend the songs accordingly. I mean, they were like, this doesn't looks nice, this doesn't looks visible, or नहीं मम्मी नहीं बनता है. So I said, okay, I agreed with them. We did do. But later on, Wing came up with that feature of moods. Okay, I think yeah, Wing was the first. Wing or Gaana, one of them was the first one, which came up with the feature of moods, and on the basis of moods, the songs were suggested. So that time they had, oh, ma'am, you had said this, we should have implemented this. Okay. The next type is the level base. So you can do sentiment analysis at the word level. So if the sentence is given as the movie was good, so you try to identify the sentiment of each word and total them out. Okay. The movie was good, but the songs were not good and the locations were good. Likewise, so you try to figure out for different things and total them out. You can do it at the phrase level because when word level, na, typically I myself while I was doing while doing my PhD, I was developing a classifier for sentiment analysis, and we came across that word good was getting classified as negative. Now this was a huge challenge. Why is this word? Because we don't want to use the existing dictionary, which was not very much detailed. We want to make a domain specific dictionary. I was working on a movie domain reviews, so we wanted to make a domain specific dictionary, and the word good was getting classified as negative, which was really a trouble for us. Then we actually saw, like, try to identify why is this word getting classified as negative. When we looked through it, we could realize that word good is appearing most of the times in negative reviews along with the word not. So movie is not good, the songs are not good, the director was not good, something like that. Okay. So more than positive reviews, this is occurring more in negative reviews. That is why it was getting classified as negative, and we had to deal it separately. So we went to phrase level, where you take up a phrase, a verb phrase, a noun phrase. So then not good used to come together, and then it would get classified properly as not good is negative and not is negation, so good is positive. Likewise, people also attempt to do it at sentence level, at paragraph level, and at document level. People attempt to classify the sentences, attempt to classify the paragraphs, and attempt to classify the documents. The languages, yeah, could be done on any of the language, but popular is English. A good amount of sentiment classification work is being also done on Chinese, Vietnamese, and Arabic language. Okay. Also, I find a good amount of work being done right now, even on Marathi literature. We have faculties in Mumbai University and IIT Bombay working on it. And there could be approaches such as supervised, unsupervised, or semi-supervised. So when you have a target attribute, as we saw yesterday's example, we had attribute as fraud, which gives it a specific characteristics. So that type of work is called as supervised. When you don't have it, you just have the reviews already. Okay, when you're learning, when you're making a model, you just have the reviews. And from that, you to make them into groups and then identify what is the characteristics of this group. That is unsupervised. And there are different hybrid approaches which try to combine these, which try to come up with new ideas, and likewise. Okay. I'll give you one small example. We worked on a project where we had really less number of reviews. Okay. So what we did is we just added a negation word at an appropriate position and change the polarity of the review. So if I had a review as the restaurant, the ambience was not good, and this is tagged negative. So I changed the negation. The ambience was good, and I put it in positive reviews. With this, we were nearly able to increase the dataset size by 1.8. So if there were 100 records initially, we could come to 180 records. Yeah. And I highlighted this because I had worked for my PhD, I had worked on this specific zone. So in your project also, you can, when you do survey, you have a lot of things that can be done. But whatever part you are going to address, you can highlight them like this. Okay? So you can say these things are possible, but I am doing these things. I can't do everything. Okay. Now let us understand what is a typical. This is a text classification approach. This we attempted to use for sentiment analysis. Okay. So you will have reviews. Let us say you see Book My Show or you see any of this, where the reviews are. There will be reviews about movie on Twitter. There'll be reviews about that movie on IMDb. So you have these reviews as tagged positive or negative. Maybe they are already tagged, or maybe you have to manually tag. Okay. Now have a look at this. This is typically an example of how a review is written. So this is a real data set of movies, okay, which was 1,000 positive reviews, 1,000 negative reviews. Each was one in file, one text file. Okay. Now I'm zooming it slightly. Can you just have a look at it? And there could be even stories written somewhere at the beginning or the ending. There could be, the sentiments mentioned in the review. But the reviews were typically like this. The smallest review was 3 words. The largest review was having something 2,000 and something words. 3 words was simple, elegant, and nice in this data set. Okay. Now, when you have a data like this and you want to classify, is really a challenge. This is called as unstructured data. I can also show you the data which you might have opened. This is the data which you have downloaded, sentiment labeled sentences. Again, it might have come in a zip folder and which you have to unzip and put it over here. I'm not sure whether it is yeah like that. But you can open any of this. Let us say I open Amazon cell labeled. Okay. You can open it in simply Notepad or you can simply open it in Notepad plus plus, Excel, anything. But this is one review, so there is no way for me to plug in here in the US unless I go by a converter. Okay. So this is the review and this is the sentiment. 0 and 1. Okay. Good case, excellent value. It's 1. So this is positive sentiments. Great for the jawbone. Positive sentiments. Tied to the charger for conversations lasting more than 45 minutes. Major problems. Okay. 0. That indicates that the sentiment here is negative. Just compare this data set with the data set that we have already dealt up till now. It was properly in a column format. This is the column, these are the values, this is the column, these are the values. Now that is what a machine understands. That is what a system understands for doing my ML. It doesn't understand. If you give this, it will not be able to, it will say that dimensions are mismatching. Okay. So you need to first convert it into something that is an understandable format. Okay. Now, how do you do this? For which you do something called as vectorizing or converting your data into frequency vectors, or we are going to do it by TF-IDF. But for simplicity, I've attempted to. This is actual I converted the data set. I was using Java at that time. Okay. Right now it is Python available, but using Java, I converted the reviews into the text. So if you observe the very first column, is every individual words in the review. So it is if you just look at the first 10, the films adapted from comics books had hardly plenty of success, whether they are about superheroes, Batman, Superman, Spawn, or geared towards kids. This was the first review. Okay, and I think there is slightly more also. Okay, and if you look every column, okay, you look every column that is one document. Okay? Now, in this one document, so this was the first sentence in the first review. There were many more sentences. In this document, that is, if you look at column B, that is first document, the word film occurs once. Okay, the word from occurs 8 times. Same way, if you look at success, it occurs more or less, some 1 or 2 or sometimes in this matrix. So that is why you call that one dimension. That is one dimension you see is the terms, and the other dimension you see is the documents. So if you just take any value over here, let us say I take this value as 6 over here, it indicates that in qth document, okay, that is q minus 1 actually because a is the words one. Okay, so in the qth minus 1 document, this word from occurs 6 times. Now observe typically the frequency of from, okay, that's the third row. Observe typically the frequency of word of, okay. Observe the that is of is ninth row, okay. You see the number 9 and see the frequency. Observe the frequency of word the, which is 23rd one. What can be observed? Are they too large in number? Are they not there? Are they large or less in numbers? Can you just text me? A semi-supervised, I'll tell. Okay. But could you just observe that? Yeah, these are really large number. The frequency is high. It's really high. Now, when it is large, we should see what it is, right? Let us see what it is. Now, see the words. The words are from, of, the. Do you think these words are really important to us? I mean, do you think they will make any sense in text classification or sentiment analysis? No, they are not important, and that is why we call them as the stop words. Typically, when you write a Google query, it just simply throws away the stop words and then searches for the query. Unless and until you explicitly mention that in double quotes and all this word has to be there. Okay. Yeah. You are asking here about semi-supervised. Okay. Semi-supervised, I'll give you an example. Just let me complete this, okay? Because otherwise we'll lose the track. Typically, observe the success ka also, okay? Yeah. Now we will come to, so this were all the positive reviews, okay? This is the term document matrix which I've printed just for positive reviews. Similarly, you can see the term document matrix printed for negative reviews, okay? The sequence of the terms are purposely kept it same, okay? See, the three sequence is purposely the same, but again try to make some observations about of, then the starting of the word the from and the. Again, it is typically the same, they are typically large, but try to have a comparison of the word success in this negatively tagged reviews versus the positively tagged reviews. Observe, is success occurring here? How many times is occurring or is not occurring? And if occurring, how many times? And observe here if it is occurring how many times. So this is the top one which you see. Sorry, one minute, huh? I lost one. Yeah. Okay. The top one that you see is the positive term document matrix. The matrix for positively tagged reviews with these terms in the same order. The document that you see at the bottom is the matrix for the negatively tagged reviews. What can you observe for this word success? You can either unmute or you can type on chat and make a comment. Prepositions is not important. That is what we just saw. That is the of, yeah, this is perfectly attached. But what I'm trying, I want a little bit of comment on this just term success. Success, see how it is occurring in positively tagged reviews. So this is first review, this is second review, this is third review, or first document, second document, third document, fourth document success is not there, fifth document not there, sixth it is there, and likewise there, not there is there. Same way for negatively tagged reviews. First document not there, second not there, third not there, somewhere it is there over here. Then again many documents not there, somewhere there over here. What observation can you make about this? Friends, either you can unmute and speak. Okay, very nice. Success is more in positive reviews, occurs more in positive reviews, occurs rarely in negative reviews. Yes. So this word is there many a times in positively tagged reviews, but very less time there in negatively tagged reviews. And using this, we can take advantage of this and try to give the sentiment to our word. So if we have a word which is having more dominancy in positive reviews, we'll classify it as positive. If we have a word which is having more dominancy in negatively tagged reviews, we classify it as negative. So this is how you will get the classified terms, which will be called as your uh, sentiment vocabulary. What is your typical vocabulary? All the terms which are there in your document is your typical vocabulary. And when you have it classified based on this, based on the dominancy. Now, what is dominancy? There are different measures for dominancy. We'll discuss them. But right now we are simply looking on the basis of the frequency. It is more frequent in positive reviews as compared to negative reviews. So that is why you have it as classified as positive. Okay. Yeah. We'll go for hands-on. But before that, okay, we'll go for hands-on, then come back here if necessary. Any doubt? Yeah, semi-supervised was one of the doubts that is being asked. So semi-supervised approach. First understand, see if I have reviews like this given to me. Okay. So what we have given, we already have a tag over here. This review is negative. This review is positive. This review is positive. When I'm going to develop a model, I'm going to use this information, negative, positive, positive, and then develop a model. This approach is a supervised approach where you have the target attribute given to you. Okay. Unsupervised is this was not given to me. Okay. And based on the words which are there, more or less similar. So success, this group, this documents में है, I try to group them together. Success, this documents में नहीं है, I try to group them together. That becomes an unsupervised approach. But sometimes there are approaches which do a combination of this. Okay. Now, actually, I didn't wanted to show you this slide a little bit early, but since this doubt has come, I'll show it to you. Let me show this. Just have a look at this model. Yeah, just have a look at this model. Okay. This is the same thing what we discussed, right? So you have positively tagged reviews, you have negatively tagged reviews, you make term document metrics, you use a classify and you get a classified terms. Okay. This is a simple supervised approach. Now then we slightly modified it. We played around with parameters for classifying and we got a new classifier. This was one of the papers. This is how, I'm also telling you how the ideas evolve. Okay. This was actually I was supposed to tell you later, but since this question is there, I'm answering it. So how the ideas evolve. Later we felt that okay, some amount of pre-processing is needed. Okay. We can do some pre-processing, we can remove punctuations, we can handle the words with apostrophe. Okay. And then you can make a model. So this was one of our research papers. After doing this, we computed the accuracy. Then what we did is we identified that good wala example I gave you, the good word was getting classified as negative. So we tried to identify the negation, and if we had the review as the movie was not good, the review is tagged negative. The review is tagged negative, that means all the words in the review are expected to be negative. But since this word good has come along with not, it is expected to have a positive orientation. So that means it should go into positive matrix. So that is why likewise we switch the words along with negation to the opposite matrix. This was one of the work of the research. Now this approach, as it is going ahead, you can call it as hybrid approach. Here I am not, here I am not using purely the target attribute. The target attribute was the review is negative. But along with the target attribute, I am using a domain knowledge that along with when word is there along with not, it has a polarity shifted. It has changed the polarity of the review. So that is why I'm putting the word good in positive matrix instead of a negative matrix. Default में whichever review was negative, all these words should go into negative matrix. So this is one of the hybrid things that we did over here, or the you can call it semi-supervised approach. Okay. Now then, after doing it, there were a few more things over here, like domain-specific rule-based classify. We made domain-specific rules. Like if we have a review as the movie is good, okay, the movie is good and it is tagged as once. That means the review is positive. Now, this review we expanded using a dictionary. There is a group, there is this resource available called as WordNet, which gives you all the related words of that given word. So, if I give it the word as movie, it will return me words like films, it will return me words like cinema. Okay. And this one sentence which was there, I can make three sentences out of it. The movie was good, the film was good, the cinema was good. It will increase the size of my training set. The larger the training set, the better is the output. So this is one of the semi-supervised approach that we did over here. Okay. So we try to expand or we try to, that is called as dataset augmentation. We try to augment our dataset based on the domain knowledge. I hope semi-supervised is clear. When we are doing combinations. Yeah, thank you. Okay, now moving ahead, we'll come to our notebook. I'm sharing the link. Is the dataset downloaded? Give me an acknowledgement. Okay, great, great, great. This is getting shared as a Google file. But see if you are able to access it. Let me also check. Yeah. So you will get, if you get somewhere over here like this, click on open with and click on Google Collaboratory. Once you open it, click on File and save a copy in Drive. So this notebook comes in your Drive. Then only you'll be able to work on along with it. Give me an acknowledgement when this is done. When you're ready with the notebook, let me know. Yes or done, say something. Yes. Nigda and Deepak are ready. Good. Aditya is ready. Okay. What I intend today to do is if we get at least 10-15 minutes by the end of this lecture, there are very few. Means typically the students are interested in application oriented jobs, but sometimes there are some students who are interested in research type of career. So if time permits in last 10-15 minutes, I'll try to brief you how should you go ahead if you're planning a research based career in data mining or data science. Okay. Yeah, so coming back to Notebook, you all have downloaded it. These are again some of the imports. We'll see them as and when needed. Let us not bother a lot right now. You can simply execute them. This is the status. Huh? You see over here, allocating, connecting, initializing. Initially, it takes some time, and then when it is done, then it will be like, okay, you see the RAM and disk. You see a tick mark, that means this cell is executed. Also, this rotation is stopped. Otherwise, you see this as in a execution step. So again, going for next one, that is where you are supposed to upload the dataset. So when you execute this, you will get this choose file wala option, and you click on choose file. Traverse in your system where you have kept this sentiment labeled dataset. Sentiment labeled sentences folder is there, and in that, let us take Amazon sales only because we saw this data set. We can take other two also. Amazon sales is about products, more of mobile products. I think it is there. IMDb is about movies, and Yelp is a group of restaurants. It's a popular group of restaurants. It's about the reviews of restaurants. Okay, so we go with Amazon. Okay, we go with Amazon, and you say open. So it'll take some time to load it. Uh, Let me know or say a yes if your data is got loaded. Like if you're done till this cell, if you see this as 100%. Okay, Deepak, Krishnan. Okay, that means it is working. Anyone, if you face any problem, do let me know while. doing this. Yeah, so your data is loaded. Now we do the same thing. You import the data. Okay. In this case, it was separated by slash t. There is no column name given. Okay. So if you just observe, it starts directly with first review. There is no column names given. So that is why you have specified over here as, okay, I'll make this slightly larger so that it is very clearly visible. So you have specified that header is none. So by default, header is true. And then you're giving the names to the column. So names is a input to this function where you specify the column names if they are actually not given. So you're specifying that the first column is the review and second column is the sentiment. Now I can very quickly make you visualize this, a little bit in a. Okay, I don't have. I'll have to go through Excel and all. I'll not do it right now. Okay, we'll see in data frame only. So your data is loaded into data frame. Once you execute this, you can execute the next thing and see the top five records. Okay, so this is your first review. So there is the no way to plug me in what we had seen over here. So there is no way for me to plug me in unless I go by a convert in. And the sentiment is negative. 0 indicates negative, 1 indicates positive. Okay, we are just able to see the data. Okay. We try to see how many records are negative, how many records are positive, as we have done yesterday also, counting by the sentiment. Okay, okay, I'll not call it as complaints, it is actually a review distribution. Okay. So then you can actually plot and see, sorry, you can first execute this and see, okay, there are 500 negative sentiments, there are 500 positive sentiments. The same thing printed just in the bracket. In case you have, sometimes you work on emotions. There are some databases which will have emotions like happy, joy, sorrow, the six basic emotions. Okay. So that time you might not have it so even. You might have happy K more as compared to disguise K, the emotions might be less. Moving ahead. Now, before moving ahead, just tell me, are you done up till this? Before moving ahead, just tell me, are you done up till this? Okay, done. Good. Good, good, good. Very good. Yeah. Now let us move to one of the visualization techniques, which is called as word cloud. You might have seen this at many places, but we don't know that this is called as word cloud. What it is, what its definition is, will right now not bother. We'll just 1 minute. I'll put it in a better format that is nicely visible to us. We'll just execute this word cloud and just try to observe what you have got. You have got the words in your data sets which are prominently appearing, which are having importance, okay? But they ignore stop words because we have set it to do that, okay? So you see phone, product, sound, price, great, battery. These are typically the words which are related to uh, electronics domain or mobile domain, fit item, okay? Quality, call, one, well, works great. Your case, better, charger, excellent work. Likewise. Are you getting this word cloud? Let me know a yes on the chat. Yes. This is one of the popular visualization techniques. Okay, there are many visualization techniques. This is the one. Let us try slightly doing, will not tamper our notebook a lot, but we will do one simple thing. Just observe this carefully. Yeah? एक बार आप शांति से observe करो. I'm executing this cell where we upload the data. I've come up, okay? Google.colab जहाँ पे है. I've come there. I'll choose the file and let us say I choose here Yelp labeled. Okay, I choose the file as Yelp labeled. Earlier we had uploaded the Amazon cell labeled. Okay, now this same line that is DF, I'm putting it over here as DF Yelp. Okay, and I'm loading this Yelp labeled into here. Okay, so one change I did is I uploaded the Yelp file. You don't do it right now. I'll give you time to do it. Okay. Then we changed it to Yelp label. This .txt should be there. The complete file name should be there. Okay. And we gave it this data frame was df. This data frame's name is df Yelp. And this we will give as the input to our word cloud. And let us see what happens. So we have this df.reviews. Now we'll do this as df.pl, but we'll have to, yeah, we'll have to execute execute this one, dfel. Okay, and then I see execute the same word cloud wala code, but instead of df, now I have dfel. See the important words, see the change in the important words. Place, service, food, good, delicious, restaurant, yeah, and whatnot. Burger, friend, well, just try doing this. What we have done is we have just loaded Yelp file instead of Amazon cell, and we made this as a new data frame. I copied this sentence I copied this sentence exactly as it is, this command exactly as it is, and just gave it a new data frame named dfel and changed this text file from Amazon text to Yelp labels. And text me a yes if you are done doing for Yelp. Come on, then why to leave? Yeah, पहले ये कर लो चलो. Any problem doing this, let me know. But don't save it as DF, huh? Because our remaining code it will affect. Then you will get the remaining data output related to restaurant reviews. It can be done, not a problem. But we are intending to do it for a product, the mobile products output. If done, punch me a yes. Was this for previous one or I don't know? So yes, you say that Yelp done. You completed, say Yelp done. It'll take some time. Do it. Okay. See the code if you want to. What I have done over here. Sorry. Yeah. So I just executed this cell that is Google Colab. Uploaded the Yelp file in the selection. I selected Yelp. Copied it as it is. Don't waste your time typing. Just select it, copy it, and don't overwrite this. First, make a copy of DF or paste this somewhere aside, and make this new command df Yelp the same as this one, but only instead of this Amazon cell label text, now we are having Yelp label text. If you try to execute this code at the moment, it will give you an error. No, sorry, we have already loaded it, so it will not. It will not. Yeah. Yelp done. Okay. Anand Krishnan, Snigdha, Sohanlal, and Shubham. Only four of you are able to do. Others, any problem? No, Yelp done. Okay, fine. Good. So moving ahead. Can we also very quickly try for like we saw for restaurants, we saw for products. Let us quickly see for movies also what is a word cloud. And they say picture is worth 1,000 words. So it is really see there are at least 1,000 words. So I'll do same thing again, but now I am loading. I'm choosing the file as IMDb labeled. So IMDb is movie database. It's getting loaded, and just like this, I'll create a new data frame, which I will call it as DF movie. Okay, and DF movie mein now the text file that will be loaded is this IMDb labeled. Okay, and this DF movie I'll copy and I'll put it back into this word cloud code where we have, yeah, and see what are the popular words over here. What are the important words? Film, movie, character, see, even, great, actor, scene, acting, one, good, bad. Because these are reviews, so good, bad is also getting characterized well, okay? Scene, performance, music, story, director. Okay, text me a yes if you are done so that I'll go to explaining what is IMDb done. Yeah, IMDb done. Okay, text me IMDb done so that I go to explanation of explaining this word cloud. Okay, fair enough. Even done or not done, we for some time keep this back as DF. Okay, we'll keep this notebook consistent with DF. So from DF movies, we just change this to DF and we get our word cloud related to products, electronic products. Most of them, I think, is mobile. Yeah. Now just have a look at the code. So this is a library available word cloud, and you are also using stop words. Okay. Now you're taking stop words over here. Okay. And DF is our data frame, which is consisting of two columns. What are two columns in our data frame? Can you write in chat? What are the two columns in our data frame? This is our data frame, DF. It has two columns. Can you write in chat? What are the two columns in data frame? Yeah, one column is review, other column is sentiment. Perfectly right, Anand Krishnan. Yeah, good. Okay, good, good. So, when I want to access this column review, I write it as df.review. When I want to access this column sentiment, I write it as df.sentiment. So here you are accessing this column df.review. Okay. So you are looping through all the reviews which are there. One review, like if you see over your notepad, this is one review. Okay. And for which you have created a for loop, you are going through each review at a time. Okay, and for each review, you are accessing one word at a time. So that is why it is okay. We'll come to one word later. So each review, so there is no way for me to plug it in. This is loaded into this val. Okay, is loaded into a variable val. So you are getting your first identifying or your first taking the string part out of it. So you're converting into a string because this is in a machine readable format. Okay, so you convert it into a string. So that is string of val. The function is available is string of vals. Now then you print it or you divide it each into one word that is tokens. Okay. So you divide this entire sentence into one word each. So there is no way. As you had seen in that first column now, which I had shown you. So you divide it into tokens. And this is the pre-processing part that we are doing over here. We are converting all the tokens into the lower case. Okay. for I in range of length of token. Okay. Tokens of I is equal to tokens of I dot lower. Okay. So dot lower is the function to convert it to a lower case. Remember, at this time, you just have the tokens over here only for first sentence. Let us say for loop is in the first iteration. So this tokens will have only the first sentence ke tokens, first sentence ke words. Okay. In the next iteration, this val will have second sentence loaded into it. Okay. So in this second sentence, there will be only those tokens, four tokens. Words is splitted. And default split mechanism is on a space. If you want to split the words on something else, so something like slash t and all, then you can specify it over here. What is the separator? Okay. And it will split on that mechanism. Okay. Yeah. So default is space. And then what you do is you again join it back. So here it were different individual words. Now you have done pre-processing, you have converted everything to lowercase and you then again make it together. So now this is one sentence again with everything into lowercase. That is why in this you never see any word which is in a capital one. Okay? Although in actual review there are words written with a capital. But why do they do this? Because probably the word so will be taken different as compared to somewhere it is so in not in a capital case. Okay? This is one of the pre-processing techniques available. Why is this done? Understand it? I'll tell you. Okay, why is this done? I'll tell you why pre-processing is done. But before that, you create the word cloud, the object for the word cloud, okay, and the parameters you're specifying 800 by 800. Background color is white. Stopwords you are saying that stopword. These are the stopwords, so don't print them. Font size and generate comment words. Okay, and then you are actually printing it using a plot. We have seen this earlier, right? Yeah, when we printed any of the plots, we just give what we want to print. Now here we are giving the input as the word cloud, which we created over here. So this created word cloud is given as the input over here. Again, this is the size of the plot. You can change the size of the plot, make this plot larger or smaller. Okay. Just have a look at this code. I'll be back in 2 minutes. There's a bell ring. Yeah. So any doubt with word cloud up till now? And again, with parameters, there can be many parameters to every function that we are using. You can, just click on this and then search and explore more. Uh, yeah, so no doubts. Anyone, any other doubts? If it is clear, just punch me clear. Say yes or clear. Anything. Okay, no doubts. Clear. Okay. Cool. Yeah. So moving ahead, what we have done up till now is still also the same thing. The We have done just the pre-processing part of it. Okay, we have not or we have not done anything up till exact classification or what we did till yesterday. Now we are attempting to start with the part. We are dividing into X train, X test, Y train, and Y test. What I realized in yesterday's session, this thing was not so very clear. So what I'll try to do is I'll very quickly uh, yeah. So you have printed over here as df.head. You can also print df dot shape. Yeah. You can try just doing this df dot shape. So it shows you there are 1,000 records with two columns. So in data frame df, we are having 1,000 records. Okay. Let me quickly put it simultaneously in the description. Fair enough, the device is not turning on. I'll not bother about it right now. Okay, let us come with discussion only. Let me try if it gets turned on after some time. Fine. Let us not bother about this right now. Okay, we have seen that there are total 1,000 records. Now we are dividing this data frame, one data frame, which has 1,000 records and two columns. One column is review, another column is sentiment. Okay, so we are dividing this data frame into these parts, that is X train, X test, Y train, Y test, where you are putting reviews. Whatever is over here goes into X. Whatever is over here goes into Y. Okay. So all the reviews have gone into X train and X test. All the reviews, all the sentiments have gone into Y train and Y test. But it is divided. So not all reviews are in X train or not all reviews are in X test. Out of all the reviews, 80% are there in train and 20% are there in test. By default, this ratio is 80-20%. Okay, so let us quickly have a look at it. Okay, we can just simply say print xtrain dot. Okay, I have to execute this cell first and then this cell. Yeah. Oh, sorry, not 80-20. It is 75-25. I'm really sorry. It is 75-25. So xtrain में we have got 750 reviews with one column, and that one column is review. Okay. Same way we can see, you can also type it simultaneously. We can see X test. X test, how many it is? X test is how much? I'll not execute. I want answers from you all. What is the shape of X test? Same way we can also print Y train. ओके, इसको मैं वाइट टेस्ट कर देती हूँ and I'll take this and make it as white. X of kept it as capital, Y is kept as small, typically because X is predictors and Y is being predicted. So predicted is a single attribute. Predictors will be more. As of now, still we have a single review in X, but we'll be dividing it further. Don't worry. So X train is 750. What about Y train? What is the shape of Y train? Okay, sorry. Initially, I had asked X test. Yes, X test is 250. Okay, and what? How much is Y train? Sorry. Yeah, how much is Y train? 750. Perfectly right. So X train and Y train, both of them are having 750 entries into it, but X train has reviews, Y train has sentiments. You can also see this by simply printing X train. It will truncate some of them. That's okay. Yeah. So all the reviews are there. So it says there are 750 reviews. Same way you can also print Y train. There are 750 sentiment labels. This is positive, negative. Okay, 750 sentiment labels. The same way this, if I print, there will be reviews, 250 reviews. Y test will be 250 labels. Why are we doing this? We will make our model using this X train and Y train. We know the output of Y train for this X train record. We'll make the model. We will predict for X test. We'll get some value of Y and we'll compare that value of Y with the actual value of Y. That will tell us how good our model is, and that is what is testing. I hope that is clear now because yesterday I could sense somewhere it was not very clear. Can you just reply me a yes that this division of X train and Y train is clear? Or if you have a doubt, you can ask. Okay, Deepak says yes, it's clear. Clear. Okay, fine. Good, good students. Very good. Moving ahead. Now we are coming to something that is, really important. TF-IDF. Okay. Before we go to what is this TF-IDF, before we execute this, okay, if the way it works, that's fine. Let me come back to the presentation that we had. No, TF-IDF, I think I've given a link. Yeah, click on that link. It will open a document which very nicely explains what is TF-IDF. Don't look at the formula initially, it will scare you. We will generate a formula. Actually, we had very less time in this session. Otherwise, what I do typically in my lectures, data mining lectures, is I ask students will never mug up formula or will never see it directly from the book. We will attempt to generate it. Okay? And we at least come near to the formula. I've always observed the students' discussions or at least come near to the formula, and that makes it easy for them to remember it. Okay? Now, let us say there are two sentences like this: the car is driven on the road, the truck is driven on the highway. Don't take it very much कि नहीं ऐसे थोड़ी है कि truck भी road पे जा सकता है, car भी highway पे जा सकती है. It can be, but this is just two sentences which are given. We are taking this just as an example. Okay, so these are two sentences. What we do very first thing is we tokenize them. That means we take each word from here and put it over here. The car, truck is driven on the road highway. Okay, every word which is over there in these two reviews is covered in this table. See if there is any word that is remaining. It's not repeated. See, the is there repeated. यहाँ पे भी the है, यहाँ पे भी the है. But उसको repeat नहीं किया. एक बार it is written over here. Okay. Now this is called as vocabulary of your data set. Trust me, students, when I was working on my PhD work on this movie review data set by Pang and Lee, I was getting a vocabulary of length 49,910. If 49,910 columns, which words, which is really large, is really too large to work on. So that is why you need to cut short it so that you don't take all the words, you take only the important words. And TF-IDF is a technique which helps us to do that, to identify the important words. And that is this what we do is called as dimensionality reduction. So typically we say the larger the data it is better, but how much larger? Not so larger, right? So somewhere there has to be a restriction. So that is why we go with this term called as TF and IDF. This technique called as TF and IDF. These are two parts. The first part is TF. So TF is term frequency. TF is term frequency. Okay. Now term frequency is how many words are there in total? One, two, sorry, how many words are there total in this review? One, two, three, four, five, six, seven. Okay. Out of seven, how many times this word the appears in this review? TF only goes with that specific sentence. It doesn't goes with other sentence. Okay. So this appears only once. The appears only once. Car appears only once in first review. A truck is not there in first review. Truck is not there in first review, so you have its frequency as 0. Same way, car is not there in second review. That is why its frequency is, or its TF is 0. Term frequency is 0. Likewise, you do for all the words. Like if word was there, the car is driven on the road, the car is nice. Okay, the car word would have come twice in the first review. So here it would have been 2 by 7 instead of 1 by 7. So if you observe, what you see in the column A is all the values related to first review. Car is present, truck is absent. The column B is all the term frequencies related to second review. Truck is present, car is absent. Same way here, road is present, highway is absent. Road is absent in second review, highway is present. If there is truck, there is highway. Where there is car, there is road. Now this is simple TF. But we have also made one observation. So this tells us which term is more important in a review. If term is repeatedly coming in a review, that means it is more important in that review. So that is why it will get a weightage over here. In older days of research, only TF was used. IDF was not there in very early ages of research. But what happened, people, so that their pages should get importance or their text should get importance, they used to just keep on copying the same word again and again so many times. So automatically that word would get importance. So TF gets biased by the occurrence of the frequency. It gets biased by the frequency. It could be very easily, एक ही review के basis पे वो review popular हो सकता है. So they came up with something called as IDF. Okay, and also the second reason for IDF is what we saw in the stopwords. They occurred almost in every document. It's seen here in the review document.
Hello, ma'am. Sorry to interrupt you. I guess you are on mute.
Did this happen now or it's for quite a long time?
No, no, this was only when you were showing us that page where that TF was repeatedly used. Just a
Okay,
moment
okay.
after it was mute.
Okay, okay. Then when I went to presentation that time I got mute. Thank you so much,
Yeah, welcome, ma'am.
Jesh. Thank you so much, Jesh.
Welcome.
Yeah. So coming back over here, this is clear, no? How did we get TF? This was audible.
Yes, ma'am. TF
Yeah,
could be
yeah,
used many times, and it was used so it was being manipulated. That is what we heard.
yeah. Now IDF part. Coming to IDF part. So because if you what you observed in that presentation, the word which like the, of, and all are occurring so many times. Okay, and they should be suppressed. They should be given less importance.
which are occurring many times in all the documents. So that is why this IDF was proposed. IDF, at the numerator side, you have total number of documents. So how many documents are there in total? And at the denominator side, you have how many documents is the word occurring. Okay. So you can just have a look over here. IDF is total number of documents, and the denominator is in how many documents does that word occurs. Okay. So IDF is for a word, but TF is for that word in the document, for that term in that document. Okay. But IDF is for the term as a whole, for all the documents. Now this term the occurs twice in both the documents. So this 2 by 2, so log 1 is 0, it automatically got suppressed. Same way the car occurs only in one document, not in the other one. So it is getting some importance. Likewise, other words which are occurring in both the documents are getting IDF value as 0. Okay. Any doubt till here? Or is IDF part clear, or any doubt with IDF? Okay. No, ma'am. Okay, so it's clear. Yeah. So then you simply multiply these two. Multiply 1 by 7 with zero point 0.3. You get this value 0.043. You multiply 0 with 0.03. You get 0. And then you get this, what is this called as the table of TF-IDF. Now if you observe, you have got car as the important word, truck as the important word, road as the important word, and highway as the important word. Okay. So just observe at these two reviews. Yes, these are the four words which are most important. Driven is common, the is common, truck is common, on the is common. Right? So car and road and truck and highway are the more important words in these two documents. Now, if I have to make a term document matrix as I showed you, I can ignore simply all other words and take just these, where TF-ID value is non-zero. This helps me reduce the term document dimensions. Okay, the number of columns which are there will be reduced, because this will form actually the column. Right now for understanding it is put as here as rows, but when you want to do classification, this will actually make your columns. Okay, I'll show you that also. How do we do that? Any doubt till here? If there is a doubt, say doubt. If there is no doubt, say clear. Okay, this is really difficult to understand. Now, very few people try to get it very thoroughly or very nicely through TF-IDF. Also, one thing I'd like to clarify, the formulas which are given over here are one of the possible implementations of TF-IDF. Okay, there are many different variations available for TF-IDF. It is these are listed in the Handcamper book, which I showed you yesterday. That's like a very nice book for data mining, but only term frequency was used. Then this dividing by total number of words in the vocabulary was used. Okay, just to normalize it. Because if I use here 1, 2 instead of 1 by 7 will always be a value between 0 and 1. It will be, all this will be normalized one. Otherwise, one word which is occurring many times will have a higher spike. Now this is the TF-IDF, and it will help us reduce the dimensionality in the code. So, and it will also help us vectorize. So we are making a vector. I said our data is unstructured. We have just the reviews written one after the other. You have to convert it to the structure format as I showed in the presentation, as it was over here. Okay, you need to convert it into the structured format. This is a structured format. Let me check. Am I audible? Yeah, I was audible. I thought going to presentation might it had muted, but it was not that. Yeah, might be a player by mistake pressed a mute or something. Okay, so it was a We want our data to come into this format, structured format, and that TF-IDF vectorizer is helping us do this with the explanation what we saw over here. It will make a matrix like this, where these will be your columns. Let me very clearly tell you, this will be your column, and these A and B will be the rows. Coming to the code. Now, when you execute this, okay, before explaining how do we get it and what it is and all, we have printed these two things. One is tf-idf vector dot get features. So features is the columns. Okay. So you have got this 1, 10, 100, 11, this lot of values. If you scroll ahead, you will see the text. Okay, tentatively, I'll just not print the actual values. I'll put a hash over here. I'll just see what is the vocabulary. This is all my vocabulary. These are the words which are there in the data set and which are identified as important words. So after TF-IDF, I'm getting this, right? So, and it is in C, observe it is in alphabetical order, all words with A first, all words with B, then all words with C. And what you saw before were the numbers. These are the numbers which are there in your data set. You just go to your data set and search 15G. Okay, 15G. It should be there in some review. Yes, it is there in some review. You will search for number 15. It is there in some review. That is why it has got selected over here. You can also ignore numbers if they don't make sense to you. Okay. In some cases it won't. In some cases it will. So likewise, you have all these columns. Okay. So TF-IDF, using TF-IDF, you don't see any word like the, of, is, and. Are you able to see anything of this? No. Right, so this has automatically, our IDF part of TF-IDF has handled the stop words and given us the important words. Now, how do you do this? Let us have a look at it. Okay, you have to create this object of TF-IDF vectorizer. We have already imported it over here somewhere. Yeah, this is the one. So you have imported this TF-IDF vectorizer. And we are again, just as we do it always, the typical Python style. So you have created an TF-IDF vector object, and you have given review. What is review? DF of review. You can either address it as DF of review, or you can also say it as DF dot review. Both means the same. Okay, so that is this column of your data frame. You have given the entire text as it is, all this text, not zeros and ones, only the review part. Okay, when you say df of reviews or df dot reviews, both will do the same to this tf-idf vector, and you have said fit. So you said apply this tf-idf. Okay, so this is your model, and you've done this on xtrain and xtest. Okay, so whatever was this vectorizer generated using this vector, you have transformed your xtrain. So that means basically your vocabulary was generated over here. When you did it on reviews, you identified the important words which are there in your reviews. But you have divided your reviews into xtrain, xtest, ytrain, ytest. So ytrain, ytest is sentiments, but your entire data set is divided into these 4 parts. So now from this xtrain also you are getting the TF-IDFs of xtrain. So now instead of all the terms, you are getting here only the terms which satisfy or which are there, which are generated by this TF-IDF vectorizer in this xtrain, and you get a map of it. I'll show you what this map means. Same way we do it for xtest. If you just print this, and instead of printing everything, let us say I'm printing only for one. They say control enter. Or decide to print for one more review. So 2 reviews I'm printing. Okay. So for first review which is there, its word occurs as 0622 index That is, if you go on looking in this first array, ये जो हमने print किया था ना पहले, okay, I'll print some slash in between so that it will be easy to understand. Yeah, I gave slash an x slash extra. Okay. Yeah. So this is our vocabulary that is being printed. Okay, feature name on the reviews by applying TF-ID of vectorizer on reviews column. So on the reviews column, we identified all the important words. Okay. Then we did this vectorizer application on xtrain and xtest. And now I'm showing you this xtrain wala. We have stored it on xtrain TF-IDF and we are printing xtrain TF-IDF. So when you say this 0 is the 0th review, there is this word 1622. So if you go in this index, if you go in this going on till 1622, okay, whichever is the word which is sequenced 1622 is having TF-IDF value as 0.09. Same way, 0th review, that means the first review, and the index number is this, you get this value. Yeah. So 0th review and index number is 0. This is the value. So 1 is there in this review having an importance. Likewise, it goes on for all the reviews. So what we are attempting to do here is instead of having large number of words in xtrain and xtest, we are making it smaller based on the important words which are there. Okay. Now when doing this, we have also converted into the format that we want. So if you observe, this is the first review. Okay, if you can visualize it, this is as good as 0th row, okay, or the first row, and all these places you can say that there is a term present and this is the value for that term. Same way for 1, this is the value of that 1. Let me quickly see if I can show you a TF-IDF example where you understand what. Yeah, this is the one. So all our words will be here like this. The vocabulary which you see, a very large vocabulary. So all our words will be like this as the columns. These will be the reviews. And here will be the TF-ID instead of 1 and 0. So here it is indicating simply present and absent. Instead of 1 and 0, there will be actual TF-IDF values. I'm just, yes, they have shown it over here. So see, the word another was not there, but cats was there. Okay. Another has got TF-IDF value as 0, but cats has got some TF-IDF value. Observe with and was there in all the 3 documents, and that is why because of IDF it has got suppressed and it has got the value as 0. Okay, I can punch this link in the chat. Oh, Medium, it is from Medium. Medium is a very nice platform to read the data mining related things. Okay. If you subscribe to this Medium Daily Digest, they keep you sending things which you can read every time. Daily, they send you one article. Okay. So you can simply see the shape again. So again, we had 750 reviews, but now with 1865 column. If you see this with X text, sorry, if you see this with X test, just observe instead of X train, you put it as X test. Reviews, number of reviews is 250 because X test train was having 750 reviews. This was having 250. But TF-IDF, the columns are 1865 in both the cases. Okay. Even if you print this We didn't store this somewhere. Okay, we didn't store it. But if we had stored it, we would have got it as 1000, 1865. Fair enough. Now this is available to in our data mining format. Now this is available in the format that machine understands. So what we can very quickly do is just yesterday as we created decision tree classifier, as we created AdaBoost classifier, we are taking one as logistic regression. You can take any, try out with different models. So we have taken logistic regression. So creating the object of this logistic regression LR, then LR.fit. If you remember yesterday we had done this fit and train and predict. LR.fit and LR.predict. Okay. So or we have stored this in model so that we can use model.predict. Even if I write here LR.predict, still it is going to work. It is going to be the same. Okay. And what was the input over here? Input over here is, see, yesterday we had given a capital X, but right now our capital X or X train, what we call it, is in a unstructured format. So we converted it into a structured format, vectorized format using TF-IDF. That that X and Y we have given as the input to the fit. And for predicting, we only give the X value, the testing data that we have kept aside. Just like the training, we have kept this testing data aside. We got this Y predictions. So for this review, it is predicted as Y. Okay. So how many reviews are there in how many reviews are there in this X test underscore TF-IDF? Can you quickly tell me? $250. Yes, you think that is correct. Saurabh, yes, it is correct. 250. Uh, is this getting a little bit difficult because I am getting answer from very few? Or do you want me to explain it again? Okay. Okay. Looks like you got it. If there is a doubt, do ask. Okay. So 250 are there is our text records. We have predicted, so we'll get 250 values of Y predictions. We will compare them with Y test. If you observe, Y test were also 250. So each of this value will be compared with this, and based on that, accuracy will be told to us. If you remember yesterday, accuracy was total correct prediction. So when this Y prediction matches, this is the predicted value, this is the actual value, which we have kept aside for testing. If this actual value matches with the predicted value, it is a correct prediction. If this doesn't matches, it is the incorrect prediction. So total matches divided by total predictions is the accuracy. So you've got accuracy over here as 76.8%. Okay. Now then you are printing the classification report where you get other measures such as precision, recall, F-score and support. Okay. And then we are printing the confusion matrix as we have seen it yesterday. Okay. But more than just printing the confusion matrix, today we'll also learn this function which is plot confusion matrix. Okay, which will print which will visualize the confusion matrix to us. Just the same thing put over here, that is 102, 102, 27, 27, 31, 90, 31, 90, but in a graphical format. Okay, so these are the actual labels, these are the predicted labels. What does it mean? There are 27 such records where actually the sentiment was positive, but the model predicted it as negative. There are 102 such records where the sentiments are negative actually, as well as they were predicted as negative. And there are 90 such records where the sentiments are positive, actually positive, the true label is also positive and the predicted label is also positive. Can you write on the chat what does this 31 means? Actually, what does this 31 means? Zero, true में zero है, that is actual में zero है, and predicted में one है. Can you write on chat what does this 31 means? Okay, yes, a bit difficult. Negative but given positive. Actual negative but predicted positive. So yes, this is actually 0 but predicted as positive. So actual sentiments of the people for this review were negative, but our model or this model that we made using logistic regression classified it as positive. There are 31 such records. So what is our accuracy? 102 plus 90 divided by all. All is 250. We know that we have taken 250 records for classification or for testing. Okay. Snigdha, I understand you say it is little bit difficult to understand, but can you try to like can you ask where you want to? Oh yeah, this is also called as false positive. Perfectly right. So yeah, using this I try to explain you. This is the real values, true values. This is the predicted values. Okay. Uh, True predicted as true. That is this one is true positive. Okay. Negative predicted as negative is true negative. This is predicted as positive, okay, but it is actually negative. Predicted as positive and it is incorrect. So that is why it is called as false positive. This is predicted as negative and it is incorrect. That is why it is called as false negative. So what you have to keep in mind is predicted. Predicted positive, correct, true positive. Predicted negative, correct, true negative. Predicted positive but incorrect, false positive. Predicted negative because this is 0, that is why predicted negative but incorrect false negative. Okay. Okay, so we move on. And as we have seen now, see we did this for 250 records, but how what if there is one single sentence like this where you want to actually make an application, you pass this through a text box and you want to see that you can just delete this comment. Yeah. You want to just check if this is a really a positive review or a negative review. So you take a sentence like this in the variable text. The variable text, we have given it as the same input to the TF-IDF vectorizer object that we had created for reviews so that our dictionary remains same. Okay, initially for reviews, we created this TF-IDF object, TF-IDF vectorizer. And to this only we had given TF-IDF vectorizer कोई explain दिया था, कोई test दिया था. So same we are giving this text as the input. So it will make our text features. Okay. Now this text features we give as the input to the model.predict. When we made the model, it was model.fit. That is making the model. Okay, that is fitting the model. When you are attempting to use that model and predict for a new record where you don't know what is the review is, that time you use model.predict. Okay. And it is stored in predictions. So we are printing the text and we are printing the predictions. You can see excellent Bluetooth headset is predicted as 1. You can try with other text over here. You give something other. So I can say try to change this as worst. Let us see if it works. Not necessarily it will work always. Or sometimes it might give an error also. Yeah, so worst is classified as negative correctly. Good, let us try whether it is doing correct things with good. Yeah, it is classified as positive. It's quite good. This is working nicely. This is working. Okay. Do you want me? Some of you find if they find this part a little bit difficult, I can explain this part again, or I can tell you a little bit. I have two options. We have 15 minutes. I have two options. Either I can tell you from little bit from research point of view, or I can explain you this part again. Let me know what do I do. So if you are looking for data science from research point of view, yeah. Dissatisfied with Bluetooth headset predicted as 1. Yeah, so this is a wrong prediction. So dissatisfied was not correctly classified in the dictionary. Okay, research point of view, two of you are seeing research point of view. Regarding the accuracy, how can one increase the accuracy from 76 to 90%? Excellent. I'll show you how do we. This is what we do in research. I'll show you how do we do it. Okay. Quite a few of saying suitable is also said as zero. So suitable को negative कर रहा है वो classify. This is one of the wrong classifications. Yes. See, because when there is 76% of the accuracy, the remaining is incorrect. This is what also I'll tell you when I was showing you this presentation. Okay, let me know again if I'm audible or by mistake if I go mute. Okay, am I audible?
Yes, ma'am, you're audible.
Yeah. Thank you. So when we did this model first, and I got a quite good accuracy of 72%. Okay, when I proposed my own classifiers, I got an accuracy of 72%. I was very happy. I thought my PhD is over. I went to my guide and said it was 69%. Now the new classifiers are giving good accuracy. They're doing really good. So can we I thought that is, my PhD will come to an order. My guide asked me what is that remaining 23% and that made me okay. So I have to work quite a long way right now. So what is that remaining 23% to identify? We tried to look at each problem, tried to solve it, and slowly it went on increasing. This is a research aspect of it. I'll try to explain you from each of the point. Like just say one model where this gave us basic of 77. Then we try to do a little bit of pre-processing. I'm showing you what we did in pre-processing. Okay. Yeah. If we have, this is again the term document metrics example which we were seeing earlier. So there is first review, which has this word is, which has the word not. There is second review, which has the word not, and it has one more word as isn't. There's this third review where, okay, here the word not is present 3 times, and the third review is and not both are present 1 time. So this is simple term frequency, okay? This is not by division. I have not done division over here. This is just a count. So remember, isn't isn't it same as is and not? Shouldn't instead of isn't happening a separate column, should it not be converted into is not? Now traditional approach of pre-processing simply said remove the punctuations. So isn't gets converted to like this, and it happens to be one dimension in the data set. It still exists, and it adds to the dimension. Instead of that, I thought if we can change this isn't to is not, I will have this one added over here. So this will become 2 and this will become 1. So my review will now, my matrix will look like this. This is much better for data mining. See, this was having more columns. Here the columns are reducing. This was sparse. Here it is getting dense. Both the points are good for data mining. Okay. So what did we do? Did is I just did a control F and searched what all places apostrophe is there in my data set. So I got possibilities like this. Wherever the term was ending with apostrophe NT. Okay. So I just replaced this by space not. So wasn't became was not. Same way if it ends with apostrophe S, like that was replaced with that is. Like this, all the rules which I just looked at the data set. This was suggested to by my guide. My guide says looking at the data set is a data manthan. I mean, at least first 3 days he didn't allow me to go to think anything else, no algorithms, nothing. Just study your data. One of the assignments in studying my data, since I was doing a movie review analysis, on a Sunday I was supposed to watch 2 or 3 movies, wait in the corridor outside, and listen to what people speak about the review, about the movie. What are the reviews? See, this is actually unethical thing. It is intervening into their privacy or the discussion, but this was the need of the research that was being done. So how do people give the review? That was necessary to understand. So that is data manthan. So you look at the data and then you decide what is to be done. This is more of data science. So as you were asking somewhere yesterday, what is the difference between data mining and data science? So data mining, I would have simply removed the apostrophe. The standard technique is remove the punctuations. But here it is observed that removing the apostrophe doesn't reduces the dimension. It's still there in the dimension. So making it intelligently changed to the mapping words. So if I make it to was not instead of wasn't, this was will go into the column of was, not will go into the column of not, right? If was not there, or even if not was not there, then it will get added as column. But at least it is better than wasn't. Okay. Yeah. So this is one of the things what we did in pre-processing, and we got the improvement. What I showed you over here. So after doing classifiers, we had got 77.2. After doing pre-processing, we got 78. A slight improvement in the accuracy, but when you try to work towards now, every small thing matters, and this will have its repercussions ahead also. So then once we did the pre-processing, we observed this part. Let me show you. Okay, let me also show you what are the possible things that you do in pre-processing. And while doing this pre-processing, so we came across all these things. So you do tokenization. So if there's a sentence like this, these are the HTML markup symbols. It wasn't a terribly great but a predictable movie. So it gets separated out into each individual tokens, each individual words. Okay. In emoticons handling, we are changing the smiley to whatever it means actually. So we have changed it to the word sad. Okay. Then if there is a HTML markup, you simply remove it. So this was removed. Okay. Then punctuations. So by default, traditional way of removing punctuation was just to keep it as wasn't without apostrophe. What we proposed was to keep it like this. Expressive lengthening. So see, you will have R repeated many a times, and you make it, to a actual word. Because if I keep this terribly in my term document matrix, this terribly will be a different word, and this terribly will be a different word if both of them exist. So this is surely existing. If this word terribly was existing in some other review, both of them will be columns. Then doing with slang. So if it is GR8, and how do you do this? You get dictionaries for everything. You get a slang dictionary, you get a stop word dictionary, you get a stemming function, you get a lemmatization function. Okay. So when I have seen all this, I was like, my mind was going, trying the combinations of all this. Do only with emoticon handling, do with combination of HTML markup, see what is the accuracy. But when I discussed with my guide, he said, no, that will go into statistical analysis. So you will have some number of combinations and you will find out which is the best combination. That isn't enough for a work at a PhD level. So he said, you go with one or two best which you could identify right now and go for something more intelligent. But this was like there in my mind, nahi isse kya hoga, isse kya hoga. So what I did is I gave this what you see as a slide is a project of my BE students. Okay. So what they did is I gave them all the functions. I gave them, okay, these are the, look at how many columns are there, 1 2 3 4 5 6 7 8 9. Tokenization is compulsory, so we can ignore tokenization. There are 8 possible functions which are there. When there are 8 possible functions and you try to attempt a code, when you try to attempt a code in a combination, whether that function will be there or not there, how many possible functions can you have in total? There are 8 possible functions. So I do one code only with lemmatization. Then I do second code only with stemming. Then I do third code with a combination of stemming and lemmatization. Then I do fourth code only with stop word. Then I do fifth code with stop word and lemmatization. Likewise, if I have this 8 possible functions, how many combinations can I have? 8. 8 factorial. Okay. Uh, it's 2 raised to 8. Yeah, that's correct. Anya. The reason is because we are taking this as present or absent. Present or absent. So in the first combination, I don't do any pre-processing. All of them are absent. That is 0, 0, 0, 0. Then I take it as 0, 0, 0, 0, 1. That means only lemmatization I'm doing. That is 1. Then I take it as 2. So only stemming. 3, 1, 1. Only stemming and lemmatization both. 4, 1, 0, 0. Only stop word removal. So likewise, we made all the possible combinations. 2 raised to 8, that is 255. Okay. So in this experiment, there is no pre-processing done. Can you tell me what is experiment number 254? Anyone? Which functions are used in 254 or what is experiment number 254? Look at this combinations. Look at these combinations 254K. Experiment number 254. Everything except emoticon handling. Okay, excellent. Yeah, that's perfectly right. Experiment number 254 is everything except emoticon handling. If I look at experiment number 3, it is stemming and lemmatization. If I look at experiment 255, it is all the classification functions, all the pre-processing functions. So, okay. And then we found out the calculated the accuracy for each one. We actually did this on our data and computed the accuracy for each one. Likewise, they here they printed, or what you see in the table is the top 9 accuracies. Okay, you can see it on the graph. So what they identified is when you use 3 functions, and what are these 3 functions? Slang, stop word removal, and lemmatization. You are getting the highest accuracy. So this research was done by my students, and then I also used it. In my paper, I cited their paper, saying that okay, since they found out that these are the 3 best functions in my work, I'm using the 3 best functions. Okay, but coming to what my guide was saying, it has to be something intelligent. Okay, now what was that intelligence about? So just have a look at this 2 reviews: interesting and not boring, boring and not interesting. One review is positive, one review is negative. If I try to put them in the term document matrix, all the words are same with a different arrangement. Okay. If I try to classify them, both will get classified. All the words will get classified as neutral. There is no import. There is no dominance in positive terms. There is no difference of dominance in negative terms. Although their meanings are entirely different. So this is a challenge because of the syntactic structure of the sentence. Okay. What we are doing when we are converting from this sentence to a matrix, the syntax of the sentence is lost. For me, this matrix and this matrix is same, but this sentence and this sentence are entirely opposite. And this is one of the challenges that is called as syntactic structure analysis or syntactic structure. Now, how do you handle this? You can handle this using something called as parsers or language parsers. One popularly, or you see these graphs which are generated using Stanford language parser. You can simply download it. It is an executable file. You can there's just a README file which will tell you how to load the model, and you can put the sentence into it, and you will see the output. So when you know that this, just I'll try to tell you what it is, each meaning. JJ means adjective. So interesting also an adjective, boring is also an adjective. Not is an adverb. So not is modifying, adverbs give importance or they change the intensity of the adjectives. So this is the adjective phrase. Now when I have a negation in the adjective phrase, I will put that word instead of positive review into a negative review. So my matrix will get modified like this. As good as the word, boring is not there over here. Since it is there in a positive review with a not, I have actually added it over here. Same way, this word not interesting is as good as not there over here. I have added it in because it is occurring in a negative review with a not. I have added it in a positive matrix. So now you can see interesting can get classified as positive and boring can get classified as negative. This is one of the challenge. Another challenge, there are different ways of handling this. This was our way of handling it. There are different ways of doing it. You can come up with your own method. Okay? If you look at a review like this, a visually flashy but narratively opaque rapid exercise in style and mystification. This is typically for action movies which don't have stories. Okay? Uh, you can imagine any action movie which doesn't has uh, not great style, because action movies should be compounded, should be augmented with style and mystification. Then they make great movies. That is what is typically assumed. But this, they say that okay, this is an action movie, but there the style and mystification is not there. So that is why I can't, when you have this conjunction but, typically observe all the sentences where the conjunction but is there. The second part after the but is more important. Now, visually flashy, okay, this goody part is there, but this is not there. Okay, you have done this correctly, but this you have not done for last 10 days. So that second part is more important. So we came up with a customized classifier. This is what is hybrid approach or a semi-supervised approach. If I had simply given this review to a classifier and classified it, it would have been a supervised approach. But this is a semi-supervised approach where we are using the morphological importance, the language importance, its language related details to identify everything that is there before the but should be ignored. Okay? The stopped words get ignored. Also will not simply sum the polarity. Just in traditional approach, all the polarity values will get totaled. Will not simply sum it. But if I say it is good, and it is very good. So good is an adjective, makes it the review as positive. But when I say very good, very is an adverb, which is modifying the adjective good. So that time, simply instead of adding, we are multiplying the adverb with the adjective to give it more importance. So instead of adding the adverb, we are just multiplying the adverb with the adjective. This will give it more importance, and others can be added. There are, if you go by Stanford Parser, it gives 54 such dependencies, language dependencies, and we played around with each possible dependency. There is a copulary verb, there is a negation. So if there is a negation, this part was handled using negation and things done. So likewise, research is no specific thing defined. You have to identify what it is, how it is, and this is how the model which began in first year. After every year, we went on adding one thing, one thing, one thing, and we got a sophisticated model like this. So where you have pre-processing, where you have done negation handling, where you have done syntactic and semantic analysis, and then a complicated model. And this is a way how you should write your conclusion. See, now you don't have so much time that you spend 5 years and come to this year's or this type of conclusion, but a baseline approach which already exists give this accuracy. What do? They do something like this. These are the problems that I have identified. I have attempted to solve them, and I have improved the accuracy from 69% to 72%. And while improving the accuracy, I have done this thing. I proposed my new classifiers, which will do this. Even if you write your conclusions in this format, you write your conclusions in paper and the reports in this format, it makes it an impressive research. Okay. Yeah. So I typically I included the students example to tell you that okay, students also do this, because when I try to tell work related to my PhD, people say okay, people do it in PhD. What about student level? It's difficult to do at student level. No, students can do it. Yeah, thank you. That's all from my side. Any questions you can ask? Yes, yeah, Ajay, this is a very nice and very good question. Ma'am, over here, can the sequence of functions applied change the result? Yes, it changes the result, and that is why we had decided if we have to apply, we had decided a sequence. We go in that way. It makes a difference. So you can also experiment changing the sequence. Then you will have more combinations. Then you will have to go in the permutations and combinations format. Here we simply did a present and absent format. Emoticons not used, others used. Okay, you had answered earlier. Okay, fine. Yeah. Yeah, over to you. If there are any questions anywhere else I've missed, please let me know. Or if there are any questions right now, you can tell me. Before going to questions, one thing that I might forget, just explore these slides, Kaggle data set. Kaggle may you can go and login, create your login. So whenever there is a new competition that is being launched, okay, they will tell you that there is a competition launched. Yeah, I have my account already created. I have signed in. So whenever there is a competition launch, I get into my mail. Now we might not have enough time to actually participate in each and every competition which exists. But what we can do is you can have look at what are the results submitted by other person. Okay. So like if this digit recognizer is one of the competitions, I can go into notebooks. I can select that I want to work on Python notebooks, and I get all the Python notebooks related to digit recognizer. So I can, if I want to learn about neural networks, if I want to see the code which is related to neural networks, I go here. There is explanation. There will be code along with it. Okay, this will be helpful. This will accelerate your learning. So you don't waste time reinventing the wheel. You'll get the things which are already available. You can go beyond that. Same way, I also suggest you subscribe for the newsletter of Data Mining Cup. So whenever this international competition will be announced next year, you will automatically get a notification in your mail. There is a subscribe option over here, and there are many such competitions. Okay, see if you observe on Kaggle right now, there are a lot of competitions going on, and this is the prize money which is there for this competition. I'll suggest those who are in TE, those who are in SE, to take up such competition data sets as your project. You will work on live data set. By chance, if you click through one, you will be the winner of this amount. And even if you don't click through, you will get a real practical knowledge. These are the real data sets, which if someone faces a problem, they can submit to Kaggle and they announce a winning amount. Same way data mining cup. There is also KDD Cup which comes every year. KDD Cup Kaggle are slightly challenging because everyone participates. Someone who's a data scientist with a 21 years of experience can also participate in KDD Cup, can participate in Kaggle. Typically at students level, you should begin with data mining cup. That is what I feel. Yeah, I have taken 8 minutes more. Okay. Ma'am, to what level should we, a data scientist, know mathematics regarding a particular algo? It is good if you know the mathematics related to the algo, because see, a typical application programmer, what he or she simply does is he goes on applying, he goes on figuring out what can be done, but all the possibilities are explored and tries to find out the best one. What I suggest is if you have a little bit of domain knowledge, you will make it slightly intelligently. You take slight intelligent decisions. Like, just I'll give you an example. A TF-IDF we saw today. Okay, I said we propose three classifiers. Now, how do we propose these classifiers? One very simple idea that came to my mind is, okay, TF-IDF gives the most important words in the documents, but it might not give me the sentiment words in the documents. So I attempted to find out TF-IDF of positive documents. I attempted to find out the TF-IDF of negative documents. So success word का positive documents में TF-IDF, success words का negative word documents में TF-IDF. And then differentiate. If it is more in positive, the value of it should be given the positive, the sentiment should be positive, and if it is more in negative, it should be given sentiment in negative. Now, see, initially I had given only +1 and -1. Later on, I decided based on its occurrence, based on its TF-IDF value, again we can differentiate it. So we put it in log. This will take time to explain, so I'll not go into details right now. But understanding the details will surely help you out. Yeah, yes, I hope I've answered that. Yes, thank you, Ajay. Any other question? If not, I give it over to the coordinators.
Thank you, ma'am, for solving all our queries of our participants. A gentle reminder to all the participants, do not leave the meet yet. Feedback link will be shared towards the end of the valedictory function. I once again greet good afternoon everyone, our dignitaries, resource person, faculties, and student participants. As we know, all good things come to an end, and so has our workshop. So let us conclude this event by appreciating the efforts put in by everyone present. To congratulate the participants and motivate their continued enthusiasm, we have amidst us Mr. Eldridge D'Souza Sir, Honorable Member of Eldel Education Trust, Dr. G.V. Mulgun Sir, Principal of St. John College of Engineering and Management, Dr. Rahul Khokale Sir, Head of Department of Computer Engineering, Mrs. Anita Chaudhary Ma'am, Head of Department of Information Technology, and our resource person, Dr. Kranti Ghag Ma'am. As a gesture of welcome and gratitude, I request Dr. G.V. Mulgun Sir, Principal of St. John College of Engineering and Management, to present a virtual memento to our resource person, Dr. Kranti Ghag Ma'am.
Hello, please turn off your mic. I guess
Yeah.
there is some disturbances.
Yeah,
And
I've done
yes,
it.
Principal sir,
done
you
it.
could continue.
Yeah. I appreciate the efforts taken by the resource person Kranti Ghag, and on behalf of St. John family, I offer my sincere gratitude and thanks, and we'll be meeting once all is done happens, so that this can be taken at the next level, and we can form a data miners club at the institute, and which can be inaugurated at your hands only. Thank you, ma'am. On behalf of St. John family, please accept our sincere gratitude and thanks. Also, the memento, virtual memento, let us be a real moment only at the earliest. Thank you, and once again, accepting the kind cooperations and support in future too. Over
Thank
to
you so much, sir.
Thank you, sir.
Sir, it was. Yeah, you can continue. I'll talk later. Yeah.
Sure.
I'll just say thank you right now.
Yeah, thank you.
Sir, once again I request our Principal Dr. G.V. Mulgun Sir to address the gathering. Over to you, sir.
The resource person of this particular 3 days workshop on data mining, Kranti Ghag ma'am, heads of the department, Dr. Rahul Khokale, Anita Chaudhary, the trustee of our St. John Eldel Education Trust, Dr. Mr. Eldridge D'Souza, the coordinator of this particular workshop, Brinjal ma'am, other faculty members, and my dear student friends. I know the butterflies are there in your stomach and you are hungry much of your time. Indeed, I learned that one of the question was to what level the data miner or analyst can go. If you just try to take up any of the corporate organization, who is handpicked is the one who is business intelligent, which is nothing but the tip of the pyramid of data science. Hence, you have to have the thorough domain knowledge, the commitment and contribution with reference to the knowledge, as well as here to explore and put it in statistical manner. Any organization is looking only from the point of view of how to grow and how to be stronger. This can be done only and only by the data scientists and business intelligence. I congratulate and thank all the participants and students for taking an initiative. Let us look forward. Let us try to give a more shape only The resource person has already exposed what are the competitions. As a follow-up this particular workshop, let us have within ourselves a one workshop. So on the institute, I'm going to give 2 pages, which can be done during our annual gathering also. And also at this particular juncture, in this particular students can come forward and have their own data miners club in the institute. I will extend all the facilities. So let us be there, a hackers, let us be there, a data miners, let us be there, a good citizens. So what is very, very important is your commitment and hard work, which will going to give you success. Always quote the words of Vivekananda that awake, arise, stop not, still your goal is reached. Thank you. And once again, wishing you all the best as well as Happy New Year, which is coming very soon. Over to you. Thank you, one and all.
Thank you, sir, for constantly supporting and motivating us. I now request Dr. Rahul Khokale, sir, HOD of Computer Engineering, to say a few words. Over to you, sir.
Hello, good afternoon all. Am I audible or not?
Yes, sir. You're audible.
Hello.
Yes, sir. You're audible.
Okay. So, good morning, good afternoon, one and all. Respected Principal Sir, Ali D'Souza Sir, and Binzel ma'am, and all the student volunteers and all the participants. So, your 3 days tour of data mining is over now. So, how was the tour of data mining? 3 days tour. I hope that the tour is very nice, is fruitful. The resource person really imparted her knowledge, and particularly she has thrown light on the one of the important aspect of data mining, that is mining. So text mining is also a different field, and
Hello, Rahul, sir. We could not hear you clearly. I guess you have some network issue.
yeah.
Yeah. Now you're
Hello.
audible. Yes, sir. Now you're audible.
Okay. Yeah. So the text mining is highlighted, and the text mining has a lot of applications like sentiment analysis, emotion extraction. It has one of the biggest application in the opinion. This opinion polls, exit polls, wherein the nowadays the agencies are taking the Twitter data and other social media data, and they're analyzing emotions and opinions of the people, and from that the polls in many like uh, words, syntax level analysis, syntax analysis, semantic analysis, all the thing.
Okay. Sir, we could not get you clearly because of audio, but we'll continue our session ahead. Shatakshi, can you go ahead?
To achieve whatever the problems and properly because it will cover the practice and other things. So they are program will definitely get the data mining and all the code. So in thanks to the so impact my
Hello.
students
Yes, Rahul sir. Hello.
Mm,
Sir,
no, I
actually you
guess,
are
ma'am.
not, yeah, sir, you are not audible clearly. Uh, s- Hello. So can we just go ahead with the next thing? I think Shatakshi, you can take over. Sir has left, I think.
Yes,
Sir has
ma'am.
some network issues. So we'll see afterward. You just go ahead
Okay.
with the next flow.
Sure, ma'am. I now request Mrs. Anita Chaudhary, HOD of IT department, to say a few words. Over to you,
Yeah,
ma'am.
yeah, thank you, Satakshi. Good afternoon to one and all present here. Now we are at the end of this hands-on session. I thanks to the Kranti ma'am for conducting the hands-on sessions on data mining. So the in Python also he has shown the students that how we can execute the different data mining algorithms, which are the different parameters you should consider while doing the research while considering the data sets. And definitely this is a really a trends, like unless and until you are not in very good in the data mining, the you cannot ahead go to the machine learning and deep learning domain. So this is the very basic things ma'am has covered to the students, so the final year and third year students can do the mini projects on their own, and they can find something that is lacking into the data sets, and like the give the suggestions to the Kaggle also, as the most of the data sets are available free of cost onto the Kaggle. And thanks to the CSI staff member, the members, that is my staff members, Brinzel ma'am and Monali ma'am, for organizing such a nice sessions for the students. And not last, but my CSI teams of my computers and IT students who has really headed the nice events for the academic year 2020-21 under the CSI student chapter. This is the first events, and you people has very well coordinated these events. Thanks to all the students. Those are really contributed in this event for organization and conduction of these events. I thanks to all the participants. Those are participated and gained the knowledge about the data mining insights. So ma'am also has shown the like the research things also, his her PhD work also here. So definitely when you do your masters or PhD, definitely the parameters accuracy is plays the important 0.5 or 1% accuracy you achieve in proper way. It is definitely your own contributions in that and plays a lot important role in your research. Thank you. Thanks to all of you. Over to you, Satakshi. Thank you.
Thank you, ma'am. We are privileged to have with us Dr. Kranti Ghag ma'am as a resource person. I now call upon Dr. Kranti Ghag ma'am to say few words of encouragement and motivation to our evolving technocrats. Over to you, ma'am.
Yeah, thank you, Tachi. Very good afternoon to Principal Sir. So your visionary words reminds me of our college principal Sir Dr. Bhavesh Patel. Whenever we do any activity, he is so enthusiastic and he supports us in every possible way. And if we are doing X, he pushes us to do at least X square. So I could remember my sir while listening to you. The data mining club which you mentioned, the data mining club which you mentioned, is really a helpful thing. We have AI deep learning SIG at our college. So these types of clubs, even if you meet once in a week, once in a month, and discuss what is going on new, because what we discussed in this 3-day workshops was very much of basics. But if we want to cope up with the people who win, if we want to challenge the people who win, if we want to go in the top lists in data mining and data science, we have to know, we should know what is going on latest. So these clubs do really help out. As Rahul sir mentioned, although we couldn't hear you, sir, in detail, but as you said, and you and Anita ma'am said, this is really an important field and it should be taken care of. With the entire organizing committee, including Brinzel ma'am, Manali ma'am, and all the student volunteers, it never felt to me like this is the first event that you are organizing. It is so professionally, everything on time. The meet links come to me properly on time, perfectly well managed, and the way you are doing the activities in between somewhere. If it is, if I'm you are very quickly telling me, that's really nice. And as ma'am mentioned, data mining is the basics. I have seen the profiles of the winners. All of them are having very good experience in deep learning. They have done. See, this person Andrew Ng is very pop. I'm not marketing anyone. Okay, I don't have any relation, but they say the courses by Andrew Ng on ML and DL. You get YouTube videos also. You need not do actual courses also, are very popular, and this person tries to go to basics of everything. So if you get an opportunity, surely do it. I congratulate all the participants who were very active. Like I thought I was initially asking yes, no type of replies. So I thought whether you're doing or not doing, let me verify. So I used to ask you accuracy. I used to ask you what is the number of records, and the output used to come up very quickly and very nicely. A very active participants, good, and I'm sure you will do good because you are very actively doing it. Keep these notebooks as your base notebooks. Whenever you do something new, use these notebooks, go on adding. Like every session that I take, I go on. You, if I take a session somewhere next time, you will find a lot of contents added into this notebook. So likewise, keep on upgrading yourself. And finally, to conclude, I'll say that data will talk to you if you are willing to listen to it. This is not my sentence. This is a sentence made by a very popular person, Jim Bergerson. And do think on it. If you are willing to listen to it, if you are willing to put your efforts in this, data will surely talk to you and surely talk to you in a lot of sense. Thank you so much. And thank you for this memento and certificate of recognition. Thank you.
Thank you, ma'am. I now request our student participants to turn on their mic one by one to share their feedback for the workshop.
Thank you, Ritika. I would like to say some few points. Kranti ma'am, we are really grateful for the time and effort you took to share your deep understanding of data mining in such an interesting way that it made the most memorable workshop. I personally liked your approach to make us familiar with the concepts by discussing your experience with your own students. That really gave us insights on what we should do when we come across a problem. And I am pretty sure that we will all continue working with other data sets available on Kaggle, UCI ML. And we will also participate in the Data Mining Cup next year. And I look forward to attending more lectures and improve my skills on the foundation which you have built in these 3 days. Thank you, ma'am. Thank you.
Thank you, Saurabh.
Thank you, Ritika. You can continue now.
Thank you, Saurabh. I request Ms. Brinzel Rodriguez, ma'am, Assistant Professor and Faculty Coordinator, CSI Student Chapter, SJCEM, to propose the vote of thanks.
Thank you, Ritika. Good afternoon, one and all. As all good things come to an end in life, so is this workshop. On behalf of Computer Society of India Student Chapter, St. John College of Engineering and Management, Palghar, I, Ms. Brinzel Rodriguez, takes this opportunity to propose the vote of thanks to those who have directly and indirectly contributed to this workshop on data mining for beginners. At the outset, I thank our chief guest and resource person, Dr. Kranti Garg ma'am. We are really enlightened with your knowledge and presence. We are thankful to our honorable chairman, Mr. Albert W. D'Souza, and the entire management team for their motivation and constant support. We would like to thank our principal, Dr. G.V. Mulgun sir, for his enthusiastic and constant support in the organization of this workshop. We are also thankful to our HODs, Dr. Rahul Khokle sir and Mrs. Anita Chaudhary, for their constant encouraging support to organize this workshop. A special thanks to the organizing committee, Mr. Jayesh Patil, who is the president of the CSI chapter, student chapter, and Mr. Suyog Wade, who is the vice president for our student chapter, for coordination of the entire logistics for the 3 days, Ms. Ritika for maintaining the attendance and the photo session, Satakshi, Diana, and Ritika again for anchoring, Mr. Kanish Singh and his team for handling the YouTube live stream, Mr. Neil Vadekar for handling the Instagram PR. Then in a special way, a special mention to Mithil Sankhe and Aditya Singh for all the graphical designing, Aditi and Chaitari for managing the feedback and quiz test, and also my entire CSI student chapter team for all the dedication and support. And lastly, to all the teaching and non-teaching staff for their unflinching support and coordination. My apologies to anyone who I may have missed to mention. We certainly remember your contribution and support. Our heartfelt thanks also to you student participants for the active participation all these 3 days. And with this warm words and a kind message, we move to the end of today's session and our workshop. Thank you so much. Over to you, Ritika.
Thank you, ma'am. Thank you, participants, for ensuring the smooth conduct of the event. Dear participants, feedback and quiz link will be shared to you in the Meet and the YouTube chat box. Do not forget to fill it. E-certificates shall be mailed to you within a week after cross-verifying the attendance and feedback. Thank you all the participants for being so consistent. Participants do feel the valuable feedback. Link is posted in the chat section. Thank you.